In this video, we are going to talk about divided difference operator. So how do we define this operator? We write f square bracket x just as f of x. If we have f square bracket x naught, it is same as f of x naught, which would be same as y naught. So f inside the square bracket, if there is only one x coordinate, so you simply write f of x naught, which is y naught. But let's say if inside the square bracket we have two coordinates, x naught, x1, then this operator says f on the last x, f of x1, minus f on the first x, f of x naught, over the difference between the last x and the first x. This is how this operator defines. Let's write the definition of f of x naught, x1, x2. Now inside the square bracket you have three x values. So this operator is defined as f on the last two minus f on the first two. F on the last two is f square bracket x1, x2 minus f on the first two, which is x0, x1. Don't change the order. That is, x0 is written first, then x1 and then x2. So when we are writing here f of x1, x2, we keep the same order. x1 first and then x2. Here x0 first and then x1 divided by the last x minus first x. The last x is x2 minus the first x is x0. We can further open this up. This f on x1 and x2, there are two x values inside. So whenever there are two values, you break it as f on the last minus f on the first. So f on the last minus f on the first divided by last minus first. Now let's define this f of square bracket x0, x1. Inside the square bracket there are two x values, so you break them as 1, 1. F on the last minus f on the first. F on the last minus f on the first divided by last x, which is x1, minus first x, which is x0, whole divided by x2 minus x0. We can further on take LCM, but this is simplified. The least we can do is to write f of x in the form of y. We know that we write y as f of x, so we can write y naught as f of x naught. We can write y1 as f of x1. We can write y2 as f of x2. So f of x2 is y2 minus y1 over x2 minus x1 minus y1 minus y0 over x1 minus x0 whole divided by x2 minus x0. So this is the definition of f of square bracket x0, x1, x2. This is how we expand the divided difference operator. Now let's say if we have f of a, b. Inside the square bracket you have two values, two x values, a and b. If there are two values inside, you break them as 1, 1. F on the last minus f on the first. F on the last minus f on the first divided by last minus first. This is a divided difference operator. Let's write f of a, b, c. How many values are inside the square bracket? 3 values. So you break them as 2, 2. Last 2, first 2, which can be further expanded as f on last 2, f of BC minus f on the first 2, f of AB divided by last minus first, which is C minus A. We can further expand f of BC. Inside the square bracket you have 2 values. You will break them as 1, 1. F of last minus f of first divided by last minus first minus f of AB. There are 2 values inside the square bracket. You will break them as 1, 1. F of B minus f of A divided by B minus A whole divided by C minus A. This is how we expand the square bracket. Let's write f of x naught, x1, x2, x3. So inside the square bracket you have 4 values. You will break them as last 3, first 3. So f on last 3 is f of last 3 are x1, x2, x3. Keep the same order. Minus f on the first 3, which is f of x0, x1, x2. Whole divided by the last x, which is x3, minus the first x, which is x0. We can further expand this f of x1, x2, x3 as now we have 3 x values inside. We will break them as last 2, first 2. Last 2 are f of x2, x3. First 2 are f of x1, x2 divided by last x minus first x, which is x3 minus x1. The same way you can write f of x0, x1, x2. Last 2, first 2. Last 2 is f of x1, x2 minus first 2 f of x0, x1 whole divided by last x, which is x2 minus first x, which is x0 whole divided by x3 minus x0. You can further expand this expression by opening up f of x2, x3, f of x1, x2, f of x1, x2 and f of x0, x1. So this is how we define the divided difference operator. In the next video we are going to see how do we use these divided difference operators in Newton's polynomials.